let's this going. No, I had a pen here. Somebody stole my pen. Fortunately for me, I have a drawer right behind me that has two pens in it. All right. This week, we are working on the volume of cylinders, cones, and spheres. Oh, geez, now all these people just start showing up. See how they are? No problem, Andrew. It's not that big of a deal. Okay, so we are going to be working on cylinders, cones, and really crappy drawings of spheres. So these all have circles in common. So when we're working with circles, we know that we're going to be working with pi. Sadly, not apple pie or anything really good, but just the 3.14 variety, which, while very effective, is not terribly yummy. But I guess school can't always taste good, so we're just going to be happy with this. Now, a little review. That's too slow. In a standard circle, we have a radius, we have diameters, okay? A radius is half the distance across the circle because it starts at the center point and goes to the edge. The diameter goes all the way across, but passes through the center point. These are standard definitions or properties of a circle. Now, the circumference of a circle, or the perimeter of a circle, is calculated by taking pi and multiplying it by the diameter. Now, the diameter equals 2r. And that also means that r equals d divided by 2. So in most of the equations we're going to be using, it uses r, which means you're going to have to make sure you have the value of r, not the value of d. If you have d, then you have to divide it by 2, so you have the value of r. For example, if I look at this, I see that I have an r of 4. Well, the area of a circle is pi times the radius squared. Now, in this circle, the radius is 4. And so when I calculate it out, I find out that the area of this circle is 16 pi. Now, you may be asking yourself, what is wrong with Mr. Easley? Doesn't he know we're supposed to convert that pi to 3.14 and multiply? To which I answer, ha, in a pig's eye. This is not a calculations lesson. This is a math lesson. So we're going to leave it in the form of pi. 1, because it's easier to do the calculations, and 2, because it gets the calculations out of the way of the learning the concept. All right. So this is going to be a correct answer. You do not have to do this. You do not have to do that. Now, if you are some kind of sick individual where the only way you can be happy is to torture yourself with decimal multiplication by hand, then knock yourself out. Have a good time. But I am perfectly content with this. Besides, later on in high school, when you do geometry, you'll leave this as the answer. You won't be multiplying it out anymore. You'll be staying as just pi as like a common factor to everything that is circular. Okay, so there we go. That's a little review of how we find the area of a circle. Now, you may ask me, but Mr. Easley, did you not say that we were going to be working on the area of cylinders? To which I answer, why, yes, of course. You say, pray tell, Mr. Easley, how does one do that? Well, you remember last week that we talked about this idea of the big B times H. And that big B was the area of the base of that three-dimensional object, right? Well, so now the circle is going to be our B. And B equals pi r squared. So based on our knowledge from before, we're going to take this BH, we're going to say pi r squared times h. Now, in this problem, we see that we have a radius of 6. So we're going to have pi times 6 squared times 10, which is the height. I'm going to pause a moment, let you catch up, because I see some of you are like panicking to write stuff down. So I'm going to slow down. I think Allie was about to have a seizure. We good? Okay. So 6 squared is 36, times 10 is 360. Here is my answer. And if this was, say, inches, then I would say inches cubed. Right? Make sense? All right, let's look at the first page of our homework. Now, the first page of our homework, is that big enough or should I make it bigger? A little bigger? A little bigger. So let's look at this first one here. Bigger. Leon is giving orders across the galaxy here. Now we'll see that the 6 centimeter measurement is a line that is halfway through the circle. That means it's our radius. So we're going to say r equals 6. This 3 is indicated as being our height. Now we're going to plug into the formula. So I plugged in my numbers into my formula. And now all I have to do is calculate. Well, 6 squared is 36. And 36 times 3 is 108. So I'm going to say 108 centimeters cubed. Yeah? Not too tough, right? Pretty easy to do. All right. So let's look at this next one here. So I have two numbers. I have 8 and I have 2. Now, I see that 2 is my height. Now, 8 is not my radius, but it's rather my diameter, which means in order to use it as r, I'm going to have to divide it by 2. So I'm going to get rid of the 8, and I'm going to say r equals 4. And then I'm simply going to plug those numbers into the formula, pi r squared h. Okay? Questions so far? Please ask questions if you have a question right now. So I'm going to square 4. That gives me 16. I multiply it by 2. And I get 32 pi. If you got 5,000 pi, you did something wrong. Or you hit your head. Either are certainly possible. Give me a thumbs up if you're understanding this. Cool. I got 32 pi by doing this. Pi r squared h. R is 4. So 4 squared is going to be 16. H is 2. 16 times 2 is 32. All right. Now, I'm also going to show you how to do the cones because I know who you guys are. And if I don't show you the cones, you're going to look it up and do it yourself because I know what kind of weirdos you are. Let's save the spheres for working together, say on Wednesday or something. But the cone volume is going to be pi r squared h divided by 3. So it's just like our pyramid. And now I'm feeling just uneasy enough that I'm going to verify that to make sure that I didn't do something stupid on this one. Yeah. Okay, good. I was right. I wasn't stupid. Well, I wasn't really stupid before. I just had a profound brain fart where I somehow couldn't remember. Ms. Knippen couldn't remember it either. She thought it was 4 as well. When I told her it was 3, she was like, "Are you sure?" And I said, "Yeah, I looked it up." She was like, "I didn't remember it being 3." And I was like, "Yeah, I know. That's what I did." So let's look at number 13. We'll calculate this one. 10 is pointing to a diameter. So our radius is going to be 5 and our height is 11. Okay. So pi r squared h divided by 3. So I'm going to plug my numbers in. Pi 5 squared times 11 divided by 3. Okay, this is going to be weird. So I'm going to get 25 times 11. So I'm going to get 275. I think that's right, isn't it? 10 would be 250, another 20. Yeah, 275. So I'm going to get 275 pi divided by 3. And 3 does not go evenly into 275. Um, I'm just going to divide it by 3. So I'm going to get 91.6 repeating pi. Now, you don't have to do that. The first one is just fine because it still shows that we know what we did, right? So basically 11 through 20 are basically exactly as 1 through 10, except you just divide by 3. Okay. So again, this isn't meant to be hard work. This is meant to be something that's simply exposing you to some new stuff that you haven't seen before. Next week, we're going to do compound areas, which is where you get shapes that look like this. And then you have to find out what the area of them are by certain hints that you get. So we're going to be doing those next week. They're a little more difficult mentally, but they're more like a puzzle. So I think they're more satisfying to do. So I think that makes them easier personally. Any questions on this stuff between either cones or cylinders? Any questions going? Oh, wait. Okay, that was an affirmation. Any questions going twice? Any questions going 3 times?